Good day, everyone. I am Axeljan F. de la Peña, and my topic is all about types of elementary structures, which is under the analysis of structures. So first, let's define a structure. A structure is a system of interconnected members used to support external loads. So basically, it means that to form a structure, you need to connect members, and its main purpose is to support external loads. Structural analysis is the prediction of the response of structures to specified arbitrary external loads. So, in simple words, structural analysis is from the word itself, which is to analyze a structure. So, first, let us identify structural elements. So, first is tie rods. Tie rods are members that are subjected to axial tension forces only. Load is applied to ties only at the ends. Ties cannot resist flexural forces. So as you can see in the picture, so it is subjected only for tension forces. And it is often used in steel structures such as bridges, industrial buildings, towers, tanks, and etc. It is made up of steel and is also known as tension bars. So here are some examples of tie rods. So next is beams. Beams are usually straight horizontal members used primarily to carry vertical loads and subjected to flexural forces. So we are very familiar with this. So it is commonly seen in buildings, and it is made up of concrete and has steel reinforcements, horizontal and vertical. So its primary purpose is to support weight of buildings' floors, ceilings, and roofs, to distribute them to the columns up to the foundation. So a beam can be classified according to the location of support and its shape. So first is the cantilever beam. Cantilever beam is supported only at one side. So here it is. Next is simply supported. So the location of the support is both in the end of the beam. Next is overhanging. The overhanging beam is only supported in between the beam. Next is continuous. So continuous beam is supported on both in the ends and on the middle of the beam. Next is fixed-ended. So a fixed-ended beam is supported on both sides with a fixed support or connection. Next is cantilever simply supported. So it is a combination of cantilever beam and a simply supported beam. This is it. So let us classify the beam according to its shape. So T-beam, so in the word itself, T-beam, so it is shaped as T. Rectangular beam, which is rectangular shape. The I-beam, so it is letter I shaped beam. And the L-beam, so letter L shaped beam. Next is columns. Columns are members that are primarily subjected to axial compression forces. A column may be subjected to flexural forces also. So the main purpose of the columns is to support the floor and roof beam. So we are very familiar with this. So it is also made up of concrete and has steel reinforcements, horizontal and vertical. So here is the classification of columns. So first is a tide column. A tide column is a column which the longitudinal reinforcement, which is this, are tied together with separate smaller diameter transverse bars, or known as ties. Next is spiral column. Spiral column are cylindrical with continuous helical bar wrapped around the column. So this is the longitudinal bars and the helical continuous bar that is wrapped around the longitudinal bar. So next is composite columns. Composite columns is the combination of a tide or a spiral column with a structural steel shape. So as you can see in the picture, here is the structural steel shape and the tide column. Next is diaphragms. Diaphragms are structural components that are flat plates. Diaphragms generally have high in-plane stiffness. They are commonly used for floors and shear-resisting walls. So it is commonly seen, no, in structures, no, the slabs, the walls. So flat plates, diaphragms. Next is we identify the types of structures. First is trusses. Trusses are structural frameworks composed of straight members connected at the joints. It consists of slender elements usually arranged in triangular fashion. So it is commonly used now as support for the roofing of a structure. So its members is connected by a pin or either welds and etc. So here are some of the examples of trusses and its classifications. So basically, no, the classification of a truss is based on their shapes. Next is frames. Frames are often used in buildings and are composed of beams and columns that are either pin or fixed connected. So it is a combination of beams and columns to form frame. Next is cables and arches. Cables are usually flexible and carry their loads in tension. They are commonly used to support bridge. The arc achieves its strength in compression since it has a reverse curvature to that of the cable. So basically, the cables is for tension and the arc is for compression, which is commonly found in the making of bridge. So here are the examples of cables and arch. So here is the cable and this is an arch. So that's it for this video. Thank you for listening.